Hello everyone, my name is K. Gopi. I am studying third year BTech in NIT Andhra Pradesh. Today we are going to discuss about the topic in optimization techniques, that is secant method using C language. Now you can see the contents, and first the introduction to secant method. Secant method is the efficient method for finding roots of the given f of x using secant lines of the function. It is very commonly used in optimization techniques. It is very similar to the Newton-Raphson method. It can be used as alternative for secant-Raphson method. It has several advantages over another other numerical methods for finding roots. The secant method is very easy to implement and used in wide range of applications. Now the advantages and disadvantages of secant method. Advantages. When it comes to Newton-Raphson method, we have to do derivation of the function. In secant method, we do not need any type of derivation of the function, so it is the advantage over Newton-Raphson method. The rate of convergence is very fast in secant method. When it comes to bisection method, the rate of convergence is somewhat slow. In Newton method, we have to evaluate two function in every iteration, but in secant method, we will do only once. It has some drawbacks. The secant method convergence is always not guaranteed. And next, the working of secant method. Then the main function of the secant method is to find the roots of the given f of x, and by using secant lines we approximate the slope of the function at two different lines, and then we find the root of the function. The method starts with two initial guesses x0 and x1. Then we evaluate the f of x0 and f of x1. By seeing this diagram we can understand the mathematical derivation. First, the red line indicates the f of x, and the blue two lines indicates the 2 points x1 and x2, and by finding their slope we can find f of x1 and f of x2. By using the slope intercept form we can find this expression x equal to x minus x1 minus f of x1 into x1 minus x0 by f of x1 minus f of x0. Then due to this we find the next point and we can compute the f of x2. Then by using this formula we can find the generalized equation of every value. And next we can solve a problem on the secant method. Given f of x equal to x cube minus 2x minus 5, and the initial guesses are x0 equal to 2 and x1 equal to 3. Given the error tolerance equal to 0.001 and given number of iterations equal to 10. And what we have to do is take these initial values and substitute in the f of x. We will get f of x0 and of f of x0 equal to minus 3, 14. And next we keep that f of x0, f of x1, x0, x1 values in the x2. Then we can find the x2, and again we find the f of x2, and by repeating its formula, using formula we can repeat its x2, x3, and we can find x2, x3. Then the number of iterations should be 10. The tolerance value is 0.001. The f of x should be less than 0.001 under 10 iterations. We will stop the functioning of the secant method when the value of f of x is less than 0.001. So in this case, 0.0026 is less than 0.061. So at that time, the value of x is 2.8284. Therefore, the value of the root is 2.8284. The accuracy of this secant method is almost 90%. We can find very easily the roots by using this secant method. There are some applications of the secant method. Example, we can use this in optimization for finding objective function which you can minimize or maximize the f of x. And by using the root we can find the maximize and minimize at that point, which gives maximize and minimize of the function. And we can also use it in the physics for finding some projectile motion problems, and we can find the roots of the equations. And we can also use in chemical engineering for finding the equilibrium constants, nonlinear equations. And the main application of this secant method we will use in electronics is antenna theory. In antenna theory, we use secant method to find the resonant frequency of the Antenna. The resonant frequency of the antenna is frequency at which antenna radiates maximum power. It is an important parameter in antenna design and analysis. The resonant frequency can be calculated using parameters such length, width, and other properties, media, and at which antenna operates. The antenna function that needs to be solved using secant method is impedance function. The impedance function is ratio of voltage to current at a specific point. The impedance should be in nonlinear equation. The secant method is very useful to solve the nonlinear equations and find the frequency at which the impedance is equal to specific value. That is resonant frequency. The secant method is very useful tool in antenna theory for approximating the resonant frequency. So now we will go for simulation of secant method. First, the input should be given is f of x and two initial guesses and number of iterations and the tolerable error. We have to achieve the tolerable error before the number of iteration. Then it should be convergent. After if we achieve, it is non-convergent. Then then we can see the algorithm for the secant method. We will set I equal to 1 and the I value should be less than total number of iterations, and we compute the next estimate root, that is x2. And if the f of x2 is less than tolerate, we will return x2. Otherwise it is not convergent. We will set x2 equal to x1, x1 equal to x2, and increment I value by 1. If the number of iterations is reached, the tolerance is not met, then the will deliver an error message. This is the algorithm. Now we can check the simulation, and this is the simulation. First we will include some libraries into the program, and first we will define a function x cube minus 2x minus 5. Then we create one while loop, that is condition, while condition, that is function greater than, that is error. Then we will give inputs as float inputs x0, x1, x2, f0, f1, f2, fe. Then we will take some initial guesses x0, x1, that is tolerable error e, number of iterations is 10. Then we will find, we will take f of x0 as s0 and f of x1 as f1. If they both are equal, we will exit, that is it is not convergent, and we will find this equation by using some mathematical. Then we will find f of x2, and next we will set the x0 as x1, f of x1 as f1, and next we will increase the I value to I plus 1. Then if number of steps greater than n, then it is not convergent. If the tolerable error condition is also not met, up to it will run when the f of x2 is greater than tolerable error. If once it is less than the tolerable error, it stops its looping and print as convergent, and the root will be printed. This is the program. First I entered initial guesses as 0 and 1, and next tolerable error I am entering 0.001, and next maximum iterations are 10. Then we got the root as 2.09451, that is he took 9 steps to get this, and the tolerable error is in this condition it is less than 1, so we can find that is root as this. This is the normal generalized equations for polynomial equation. Then we now you can see the code for the antenna theory application. Here we are finding the code. This is libraries are included, and we are finding the impedance. This is function. We are defining a function, and this is the formula for finding the next value. And these are the equations that should be included in the finding the impedance. And we will use the same. We'll given here inputs as maximum iterations x0, x1. Then we can check the by using this resonant frequency impedance function x0, we can find the resonant frequency that we got here is 0, 0. By using secant method, we can find the resonant frequency and the root. These are the another examples of the code and the screenshots. These are the another example. This is the code for the antenna theory. In this way, we can find the simulation for the secant method. Okay, thank you.